Hey math nerds, we're checking out Unit 3.3 special angles. Isn't it special? And we're looking at 45-45 right triangles and 30-60-90 triangles. They have a specific pattern that we can follow to solve problems rather efficiently. So we want to look at how that pattern works and then apply it. So let's give it a shot. Let's get the church lady out of here. And 45-45, 90 triangles crop up a lot in physics, in architecture and engineering, and so there's some basic properties about that. If we know this side is 1, 45-45 triangles have the legs are the same length. It's a geometry proof. We can check that out, but really I want to find out what these lengths are. Let's call it x and x. All right, well, I know if they're the same length, we can use Pythagorean theorem because it's a right triangle, and say a squared plus b squared, oh, b is the same thing, equals c squared, and c is 1. We're using 1 in this case because we're often going to use 1 as the hypotenuse in the unit circles. So we're just going to look at, it's a simple hypotenuse, so let's see where it goes from there. This really gives you 2x squareds. You divide by 2 and you get x squared as a half. And when you take the square root of both sides, you get root of the top over root of the bottom, if you like to think about it like that. Root 1 is just 1, and we'd rationalize the denominator by multiplying by root 2 over 2. So you should get x is 1 times root 2 is root 2, over root 2 times itself should be just 2. So these values of x should just be root 2 over 2. Cool. That's fine. It's not that helpful for us when we're applying it. It's helpful in the unit circle. We'll get there in a second. But I'd really like to figure out this is sort of going from here to here. I'd like to find a generic form of going from the x value up to this value. And so we can think about it this way. I want to take my x value, which is root 2 over 2. Right, I want to take my root 2 over 2, and I want to multiply by some constant. Let's see what that k is, and I should get 1. Right, I want to see how you go from here to here. So if you're trying to find k, this is multiplying by a fraction. So to get rid of that fraction, you can divide by the fraction. Right, divided by root 2 over 2. You divide by root 2 over 2. These cancel and you're just left with k. And 1 divided by a fraction is really just invert and multiply. So this is 1 times 2 over root 2. Because we are stellar, we'd multiply top and bottom by root 2 over root 2. And so you get 2 root 2 over 2. And that gives you just root 2. So in essence, what that means is if you know one side, if you multiply by this constant, root 2, you get the hypotenuse. Right? So if one side is x, the hypotenuse is root 2 times x. If this side is 3, this side should be root 2 times 3, right? 3 root 2. If this side is root 2, this side should be root 2 times root 2, so just 2. Right? We'll mess with those a little bit more. But I want you to know that if you take the short side, you could say the hypotenuse in the 30-60-90 is always root 2 times the leg. Sometimes that's how I write it to remember it. Okay, and this is in a 45-45-90. Great. Let's do the same sort of thing, but with a 30-60-90 right triangle. We like working with these because they come from these equilateral triangles. Equilateral triangles have the same legs or the same sides. They're not 90, so we can't play with the Pythagorean theorem unless we do this, unless we take a perpendicular, we drop a perpendicular. There's some nice proofs about why this is, but you might geometrically have to take my word for it. Dropping a perpendicular makes a 90-degree here. In a equilateral triangle, all of these are 60. But when you drop this perpendicular, it bisects this angle. So now this becomes 30, and this is 30. Right? So now we have a 30, 60, 90 right triangle, like that. We have two of them. This altitude bisects this angle, but it also bisects the opposite side. What's interesting about that is if this is 10, once we drop that altitude, this becomes half as much. And you can make that very generic now. If this hypotenuse is 1, and we do all this work, let's make this 1. This length is going to be half, right? So if we steal just the 30, 60, 90 out of this, the hypotenuse is 1, it's the side. Its shortest side will be a half, right? And now we have enough information to find this longer side. And so you can say the hypotenuse is twice the short side, right? That's one way to think about this idea. If you're trying to find that longer side, I know that, well, 1 squared, right, c squared should be a squared plus whatever this, I'm going to call this L for the longer side, L squared. If we clean this up, this becomes 1/4, and this is L squared. You subtract this from both sides, you get 3/4, oops, is L squared. And when you take the square root of both sides, you get root 3 over root 4, which is 2. So that's where this comes from. So, doing the same sort of thing as we did in the previous with the 45-45, we can find that if you, this is nice to go from a 1 as the hypotenuse and figure out each piece. But sometimes it's easier to think about this as the unit. You know that there's, from the short side to the hypotenuse, if you take the short side and you multiply by 2, so 2 times the short side should give you the hypotenuse. Here, short side is x, right? But you can see also from here, going from half to root 3 halves, really all you take is this and multiply by root 3, right? 1 over 2 times root 3 over 1 gives you root 3 over 2. Right? You multiply the top, multiply the bottom. So to go from here to here, to get the long side, you take the short side and multiply by root 3. So I think those two are important for 30, 60, 90 right triangles. So then maybe jot those down. 30, 60, 90s. Great. So we can use those parts to find solutions for interesting problems, or not interesting problems. Like if let's, I don't know, call this 5, right? Well, then this length will be twice that long, will be 10, and this length will be 5 root 3. Done, right? We can also work that backwards and say, if this side is, I don't know, 16, right? This side will be half as long, 8, and this side will be root 3 times the short side, so 8 root 3. Done, right? No Pythagorean theorem needed. These only work on right triangles, right? So make sure there's something right about all the triangles in there. Okay, so let's give this a shot. We're going to do it with 2 easy ones and then 2 complicated ones, and then we're out. So here we go, 45-45 right triangle. The leg here is 2. This should be 2 because it's also the same length. And C, I know that the hypotenuse is whatever the short side is, the short leg is, times root 2. So the hypotenuse should be 2 root 2. Yeah, great. I think that's that one. All right, let's, oh, I think I got ahead of myself here. If this is 10, right, This is the hypotenuse is 10. The short side should be half as much. That should be 5. And then the longer side should be root 3 times that length. So this should be 5 root 3. If you wanted to do that algebraically, you could say starting off with the hypotenuse is twice as long as the short side. Hypotenuse is 10, so it should be 2 times the short side. You divide by 2, you get the short side is 5. And then you could say, I know that the longer leg, I guess y, right, the longer leg is really root 3 times the short side. The short side here is 5, so the longer leg is root 3 times 5. I'm trying to make my s's and my 5s look distinct. Ping, done. This is really where it gets more interesting when you're trying to solve bigger pieces. So let's attack this. We know this information we're trying to solve for x. I think for argument's sake, let's call this 45 so we don't have to mess with it. This is 90. You can't do that without a 90-degree angle in here. This is 20. So I know that this short side, let's call it S. Let's call it A. Right? I know that to get to the hypotenuse, you have to take the short side A and multiply by root 2. Well, the hypotenuse is 20, so we got to get rid of this root 2, so let's divide both sides by root 2. Divide both sides by root 2. These cancel. You're left with A is 20 over root 2. Because we're math champions, we'll rationalize the denominator, and you'll end up with 20 root 2 over root 2 times itself, which is just 2. So 10 root 2 should be A. Okay, great. So let's write that in there, 10 root 2. We weren't asked for A. We were asked for X right there. So to find X, we're going to have to do this, play this game again. Right? I know that this is now the new hypotenuse. If I could draw a straight line. Oh, man, that's awful. I know that the hypotenuse is really the short side. In this case, the short side is X, right, times root 2. So let's plug in what we know. The hypotenuse is 10 root 2. 10 root 2. And that's really, you get that by taking the short side and multiplying by root 2. Divide both sides by root 2 and they cancel, and you're left with x is 10. And that kind of makes sense because if you look at this, if you drop a perpendicular, looks like it should cut this in half here, and half of 20 is 10. So this should be 10. All right, let's try that out one more time, and then we'll go from there. Pixelated. We're starting here, and we're trying to find x and y. Well, this is a 30, 60, 90, so one easy part is that the hypotenuse, this length, the hypotenuse should be 2 times the short side. Short side is 4, so the hypotenuse should be 8. Great. X isn't too bad either, because that's the long side. The long side here should be root 3 times the short side. So I think the long side is called x, the short side is 4, so the x should be 4 root 3. Yeah? Great, so we found the x. And then this part's a little bit tougher. To find y, now we're in a 45 right triangle, but we know the hypotenuse is 8. So I know in 45/45s, the hypotenuse is really the short side times root 2. I know the hypotenuse is 8, so we divide by root 2, and so S is really 8 over root 2. Because we're math champions, we rationalize the denominator, and so we end up with what? 8 root 2 over 2, or 4 root 2. Yeah, sweet. There it is. All right, so awesome. You can slice and dice 90-degree triangles, special triangles. triangles. Cool? I'll see you back in class. Bye.